go ahead and look at our notes from yesterday so we can finish them. So this is kind of all together. We're going to put both rules together. So we have an x squared, then we have x cubed to the fourth. X squared, nothing's happening to it, so we just repeat it, just rewrite. And then this one you have one base, but an exponent on the inside, exponent on the outside. So that means we multiply. That's the product, the power to the power rule. So we're going to multiply 3 times 4, just 12. And then now we have a base and a base, like bases, so we add them. So x to the 14. Okay, let's look at example 2. 2xy to the fourth, 3x squared. Nothing outside of here. So this is just going to come straight down. But let's do this one first. Everything needs an exponent. That means there's an invisible 1 if there is no exponent. So go ahead and put your 1s there. And we take care of each base one at a time. So a base of 2, we're going to multiply our exponents because 1's on the inside, 1's on the outside. So that's 2 to the fourth. And then multiply these exponents. 1 times 4 is 4. And then y, 1 times 4, y 4. And then just bring down the other one, 3x squared. Now we're going to go ahead and reorganize all your numbers first, then x's, then y's. So we need to actually find out what 2 to the fourth is. So put it in. 2, and then to get up to the exponent, use this caret top. 2 to the fourth is 16. So we have 16 times, and we multiply times 3. Then let's put our x's, so x4, x squared. And then we just have a y to the 4. So now multiply your coefficients. So 16 times 3, 48. And then we add our exponents of like bases. So x to the 6, and then y to the fourth. I don't like how that looks. 48, x to the 6, y to the fourth. Okay, go ahead and glue this in the next page of your journal. We are going to look at the next rule for exponents. So look at all of these problems. We're going to start out with just 1 through 4 right now. So it says simplify. Your answer should contain only positive exponents. So let's look at this. See how all of these are division problems? So the way we're going to figure out these problems is by expanding it out. So let's look at number 1 together. So we're going to expand it. 5 to the fourth means 5 times itself 4 times. Then the denominator is just one lonely 5. So instead of actually multiplying this and finding an answer, we are just simplifying it, and we're going to leave it with the same base. So we are going to simplify the fraction. So if you think back to rules of fractions and division, if you have something divided by itself, it equals 1. So we're going to cross these out. So anything that is on the top and bottom, you can cross them out. So now look what we have left, and let's write it. It'd be 5 raised to the third power. This 5 didn't have an exponent, so let's put that 1 there. So how did we go from 5 to the fourth over 5 to the first to 5 to the third? What happened with those exponents? What did we do? Subtract, yeah, we subtracted. So let's look at 2. I'm going to expand it out again. So there's just a lonely 3 on top, and then we have 3 3s on bottom. All right. Ooh. Let's cancel out. Anything that's on top and bottom, cancel them out. It equals 1. So what do we have left on the top then? There's no 3, but we can't have 0. What is this right here? Whenever I cross it out, what does that become? It becomes a 1. So it's 1 over 3 squared. So this is to the first power. So what happened to our exponents? You subtract again, but where does the base with the exponent go? Why didn't it go on top? It's because the top one was smaller. See how the top one was smaller? The bottom one's the bigger one. So where you put it is where the bigger exponent is. Okay, let's go to the next one. Go ahead and do 3 and 4. So when we expand it out, we're able to simplify 2 pairs, and we're left with 1 over 2. So if you look, if we subtract 2 and 3, we get a negative 1, really, right? 2 to the negative 1. So whenever you have a negative exponent, it's going to end up being on the bottom. Which is kind of weird, right? If I do that in the calculator, 2 raised to the negative 1, I get half. Math, enter, 1/2. So see where the bigger exponent was? It was on the bottom, so that means I'm going to put my base on the bottom with the exponent of 1. All right, next one. Mark them out. And what do we get? 2 to the second power. So whenever the bigger exponent's on top, it ends up being just on top. It's not a fraction anymore. All right, so let's look at our notes for today. So put this to the side. Okay, quotient of power. So the word quotient is dealing with dividing. So when we have the quotient, we are going to see it as a fraction. So when we have a fraction and you have the like bases, you're going to subtract them. Remember with multiplying, we added them. Like bases, when you're multiplying, you add them. So the opposite of adding would be subtract. The opposite of multiplying would be dividing. So when you're dividing like bases, you are going to subtract your exponents. So see how we have m and n? You subtract them. So same base means we are going to subtract exponents. Okay, so let's look at our first example. We have x to the 5th over x squared. What did we say we were going to do? Subtract them. So this is going to be x and then 5 minus 2. What does that equal? X to the 3rd. Okay, look at the next one. If you have a mix of x's and y's, you just do your x's and then you do your y's. But we're still doing the same thing. All right, so the x, we have 3 and 2. So this is x, 3 minus 2. And then y would be 4 minus 6. You do top minus the bottom. Three minus 2 is to the first power. Okay, what is 4 minus 6? Yeah, it's a negative 2. But we don't want any negative answers, so the way we expand it out, see how the bigger exponent's on the bottom? So that's where y is going to go. Change it to positive and you put it on the bottom. And then we just have x right there. X to the first power is just x. Okay, let's go to example 3 now. Oh, now we have coefficients. This is still a division problem. So why don't we go ahead and divide 10 divided by 5. If it's a whole number, just write that whole number on the top. Yep, 2. And then subtract 3 minus 4. What's 3 minus 4? Negative 1. And then we got to give ourselves an exponent here. So it's 1 minus 3. 1 minus 3? Negative 2. We can't leave it with any negative exponents. So where do negative exponents get moved to change it to positive? The bottom. So 2 just stays on top. We don't move it to the bottom because it's just a 2. We're going to put both of these on bottom. X to the first power, or just x, and then y squared. Let's go to number 4. We need to divide our coefficients. Negative 15 divided by 30. I don't want any decimals. So do you remember what you do with the calculator to give it a fraction? Math, enter, enter. So it's negative 1/2. So go ahead and write that. Negative 1 over 2. And then x and y, nothing happens to them. So keep them up top. Expand your little thing right there. Or it could be written as negative 1/2 and then x, y separately. These mean the same thing. Most likely you'll see it like this though. All right, so let's take a minute and go to the worksheet again. I'm going to have y'all start with number 5. Circle your coefficients, 3 over 2. Let's put it in. 3 divided by 2. It's a decimal. I don't want a decimal. I'm going to hit math, enter, enter. 3 over 2. It's already simplified, so we didn't actually need to do anything. So 3 over 2. And then the R's. R3 and R1. We subtract those, and what do we get? Huh? R2. So R2 is going to go on top. Okay. All right, do 6. But I don't want a negative exponent, so where's the R going to end up going? On the bottom. And it becomes positive 1, which we don't really need an exponent of 1. All right, go ahead and do 7 through 10 now. Let's look at number 9. We have 8 over 10, so go ahead and do that. If you want to put it in as alpha y equals the fraction, you can. And if you do it that way, it keeps it as a fraction. So it's 4 over 5. And then this says M3 over M3. What's going to happen there? It basically cancels out, because if I do 3 minus 3, that's M to the 0. That means I have no M's. I'm going to mark out anything that's M to the 0 or exponent of 0, because that actually equals 1. Let me show you something in the calculator. 100 raised to the 0 equals 1. 13, my favorite number, raised to the 0 equals 1. Anything raised to the 0 is 1. So this equals 4 over 5. Because those end up canceling each other out. Because it'd be like this. See how they all cancel out? And so that leaves us with just 4 over 5. All right, go ahead and do 10. Let's look on the back. All right, let's see. These are really similar to what we've been doing. Let's see. Let's do 17 together. That one looks good. Everybody go to 17. Alpha y equals, we have 12 over 10. Put it in and write it down. Six over 5. Okay, what's going to happen to a y over a y? It's going to cancel out. Let's just mark it out. It's gone. Because it equals 1, so times 1. The y is gone forever. Okay, and then we subtract these. What is 4 minus 8? -4. So where are we going to put x to the 4? On the bottom. And it becomes positive whenever you move it. All right, go ahead and finish the rest of this worksheet. And then you can talk with your neighbors, check with each other.